So the next heading, transistor as an amplifier. The next one, parameters related with transistor. Parameters related with transistor. There are certain parameters related with transistor. Parameters related with transistors. Okay, what are the parameters? First one, in the last we have drawn one circuit diagram, right? V in, V out equations we have written. What is the V in equations? Parameters related with transistor. Related with transistor. What is the V in equations in which last we have written? Tell me. V in equal to, if I remember correctly, IB RB, because no diagram in front of me, VBE, right? Equation number 1. This is input equations. What is output equations? V out equal to VCC minus IC into RC. Okay. So first parameter, current gain. Okay, current gain, transistor related with the current gain. All things we are related with the common emitter configurations. Okay, everything speaking with respect to common current gain. Current gain beta equal to, already we have written, IC divided by IB. Okay, IC divided by IB for a fixed value of what? VCE. For a fixed VCE. Fixed VCE. Second one. Voltage gain in what? Change in output voltage. Change in output voltage to the change in input voltage. Change in output voltage to the change in input voltage. Change in output voltage to the change in input voltage. Okay, change means what? I can say, here I will write AV. Voltage gain is AV, so you can put it in the bracket as AV, whatever we told before. AV is equal to delta V out divided by delta V in, which is equal to delta V in means what? V into minus V in 1. Correct? V into minus 1. If I am writing as V into, what all the things will be changes? RB is fixed. Input is changing means what will change? IB will change. But any changes to VBE? So if you take the difference of these two, VBE will cancels. Correct? VBE will cancels. So for example, I can written like this: V into minus VE1 divided, sorry, V out, right, in the numerator. V out 2, right? V out 1 minus V into minus V in 1. What is V out 2? V out 2 means VCC minus IC RC. What will changes? IC1 will come. IC1. V out 2 means IC2 minus of VCC minus IC1 RC whole divided by input 2 IB2 RB plus VBE minus IB1 RB plus VBE. What will cancel? VCC cancel, VCC cancel. So minus IC2 and plus IC1. Correct? So how I can return this one? IC2 minus IC1 into RC whole divided by IB2 minus IB1 divided by RB. Okay, sorry, IB2 minus IB1. Here IC1 alla first area, IC1, or if I am putting as IC2, then extra 1 minus will be here. Okay, IC2 minus IC1 by RC, IB2 minus IB1 by RB. So what is this? This I can return as delta IC. Correct? Change in IC current RC whole divided by delta IB RB. Delta IB RB. Correct? It's correct. So further continuing again. What is delta IC by IB? Change in output current by change in input current. One IC by IB. So just IC by IB, that's all. Change in difference in IC current divided by difference in IB current is called beta, nothing else. So minus beta into RC divided by RB. So this AV I can written as V out by V in equal to minus beta into RC divided by RB. This is equal to, not this is equal to, additionally I can write it as V out equal to minus beta into RC divided by RB into V in minus RC into, I can written like this one, right? AV means V out by V in, output voltage by input voltage, minus beta RC divided by RB into V in. Okay? Okay. Now see one point. See, this is V in voltage to the amplifier and V out. If V in is positive, if this is positive, this altogether it's a positive. If V in is positive, what is the sign of V out? Negative, which means when you give a positive signal to the transistor, you will get a negative signal. Negative what signal? Negative amplified signal. Now you are giving V in negative, so negative with negative, what will come? Positive. So V out is positive. That's what I told. How much is the shift will be here? 180 degree. 180 degree is the shift to the transistor. Third one, power gain. AP, power gain, AP. Output power, AP, output power divided by input power. Output current into output, right? Normally I can into R out divided by I input square. What is the output current of a transistor? Common emitter IC. So IC square into output resistance is what? RC. By input current is what? IB. So IB square. What is the input resistance? RB. RB is external. IC square by IB square is called beta. P equal to beta square into RC by RB. Or magnitude of AP can be written as beta into magnitude of voltage gain. This is also correct, right? Beta into voltage gain is equal to power gain. AP means ellame positive edukanamari കാരണം this sign is representing shift no other meaning to that one. We'll solve one question, right? One question. The input to the common emitter amplifier. The input to the common emitter amplifier is V in equal to 2 sine omega t plus pi by 3. The output voltage of the amplifier is dash, within bracket AV equal to 10. So 4 options: 20 into sine of omega t plus pi by 3, 15 into sine of omega t plus pi by 6. Third options: 20 into sine of omega t plus 4 pi by 3. Fourth options: 20 into sine of omega t. What will come as an answer? You are giving input to the signal, to the transistor, 2 sine omega t plus pi by 3. You will get at the output. Yeah, so you are giving this signal which is called 2 sine of how much? Sine of omega t plus pi by 3. This you are giving to a common emitter amplifier and you will get an output. What are the two conditions will be there? One is you are giving an input in the voltage. Okay, I equal to I0 into sine omega t I told. Similarly, V is equal to V0 sine omega t. So this is this voltage, this is a 2 voltage. 2 means the signal is look like this one, like this. Now your gain is 10. So output is equal to gain in AV means what? AV is equal to what? V out by V in. So AV the value is how much? 10. Output I don't know. Input is how much? 2. Sine means it's just sine, that's all. So what is V out value? 20. You got 20. So definitely 20 should come on the left side. So 3 options. Next, common emitter amplifier will give how much phase difference? 180. 180 means pi. Appo idu kuda pi extra add cheyanam. So once you give output, you will get 2 into it 20 into sine of omega t plus pi by 3. Pi plus pi by 3. Already pi by 3 is there. You are adding extra. So what you will get? 24 pi by 3, which means option C. 20 sine omega t plus 4 pi by 3. Clear? Huh? Okay. Next heading, logic gates. Finished up this one? Okay. Logic gates. Okay, so we'll write one by one. You know what is called logic gates. Logic gate means what? Some logical operations it is doing. Okay, everything in computer system also, mobile also, everything is doing in the form of binary system. Okay, mostly you have not seen. You know everything is working with a software, right? Mobile phone softwares and Android versions, phone softwares. So this software, what is there within the software? Software is a set of code. Okay, some unknown machine language code which is written. That is software. This software compilation process. Software processing. Process is a computer or mobile phone can only understand 0 and 1. 0 and 1. For example, in a very simple way I can say, suppose you are opening some application you are installed, right? So you will get a button called here installed. So what install immediately after is open. Okay, once you click on this one, what you are telling to the device, hey, please open the application, you are telling. So you are giving an open instruction. Okay, or you are giving a command. This command similar to this one. So this is a binary code. This is called binary code. This binary code we cannot understand, but the machine can understand. Okay, so this is based on some logic, something happening, and that you will learn after some years after. Okay, so this is like software. So once you give open, there are some logical stuffs we have written. This is called software. Okay, I have written some software. This software will convert open into some binary code. This binary code your mobile device can read and understand what you are going to tell this one. Okay, if you have any problem with the software, sometimes you have seen like your mobile phone is hanging, right? Sometimes. Okay, what it is happening? The mobile cannot recognize what you are doing. Okay, so it is a problem with the software. It's a problem with the software. It is not the problem with your phone. It's a problem with the software. Hardware is correct, but problem with the software. So what will happen means open means 0110101. If this code is given to the mobile phone understand I have to open it. So instead of opening this code, suppose if you have given 0, what is the only change? The last bit position. This is called a bit. Okay. 8 bit together is called 1 byte. Okay, so this bit, last bit you changed it, so it is from 1 to 0 you change it. So system will not understand what I want to do. Maybe this is a code, maybe something. If you click on open, it will get closed because some wrong things are happening in the software, so that instead of converting to the correct format, it is converting to some other format. So your mobile phone is behaving in a different way. Okay, so this different way means this software you are writing. Okay, software is just a machine code. Okay, it is a set of lines because you are writing in your notebook. You can understand what you are written. If it is given to your uncle or somebody else, he will not understand what you have written, right? Only you can understand. Same way, this only machine can understand. So software you are giving, but you are giving to software, and there are many hardware things will be there in your phone. So hardware is the software is an instructor. Okay, software will tell, hey, do like this. So software will say. So who is producing this one? That is producing by the hardware. Okay, now in the transistor we have seen, we have given one signal, transistor is giving some other signal. Okay, so that device is giving, but I am giving something. So similarly software is and it is producing something, so which means in your mobile phone will contains a lot of devices. In a simple way, these all called gates. Okay, logic gates, and logic gate is made up of dash. It is made up of transistor, it is made up of diodes. Transistor diodes ellam or particular combination connect cheyyana oru logic gates kittunnathu. Okay, suppose if you are giving 1, you want to get 1. Suppose very commonly you have learned about this gate. This is called a NOT gate. NOT gate. You are giving 1, you are getting 0. So something is doing inside this one, right? So this inside, this will consist of what are the things will be there? Either this contains diode or it is contains transistor. This will do the engineer's duty. How they are arranging in such a fashion so that you are giving like this and you are getting something. This is what they are doing. Okay, this we call it as circuit design. Simple way, at least in a mobile, like if you open, you have a green color board. Okay, we call it as PCB board. Or green color board. There are lines, at least somewhere you have seen, right? And there are connectors on. Okay, it is just like a copper wire. Okay, a green color insulator on. So there is some kind of connections. Once we look into that, we will never understand why it is drawn like that one. Adhe mari adinte logic undu. Our logics they are doing. So that item is called gate. Gate we cannot see. Once you open your mobile phone or devices, you cannot see gate. Gate is there within the silicon. Within the silicon. Silicon sollumbodhu oru bread eduthu aa bread ine 1000 slices akina. You can imagine the thickness of one slice. Okay, that is the thickness of a silicon wafer. Aa wafer melana ee transistorum diodes ella irikkanathu. So you can imagine how much it is small size. We cannot see. Normal microscope cannot see. Electron microscope only able to see what is happening. That much very sensitive. You have seen like doctors are entering to the surgery room, they have wearing that dress, right? White color dress. Similarly, maybe you have seen the people who are working for chip design, they are also wearing such dress. You have seen the people who are working for a chip designing, Intel engineers, chip design work, they are also wearing like that gloves, mask. If corona situation, okay, same our situation. Because why? Because means anything happened, very minor stuff will happen, means entire circuit will get damaged, their 4 or 5 years work will got destroyed. Okay, so that much precision is required. So full how a doctor is entering into a surgical room, the same way an engineer will also enter into a chip designing area like this one. Because ഒരു wafer சொல்லும்போது you cannot see the wafer. You can imagine ഒരേ ഒരു bread എടുത്ത് can you able to see it? It's impossible. That much very lighter. അതാണ് ഒരു wafer. ആ waferലാണ് we are connecting diodes, we are connecting transistor, and we are forming this idea, this logic. Okay, so different types of gates, that's what we are going to see it. First one, right? Okay, we will make it as a tabular column. I think that will be the best one. Okay, instead of writing one by one, we'll make it as a tabular column, many headings. First one, first column, name of the gate. First column, name of the gate. You can draw name of the gate. Name. Second one, symbol. Third one, truth table. Third one, truth table. Logical expression. Okay, logical expression. Logical expression. Analog circuit. Analog circuit. Digital circuit. You can place your notebook in an opposite way. Landscape mode. Symbol, truth table, opposite space. Yes, like this. So draw it in the way. That many heading: name, symbol, truth table, logical expression, analog circuit, and digital circuit. First one, OR gate. OR gate in the symbol. Two inputs A and B, output Y. Truth table A, B, Y, 0, 0, 0, 0, 1. OR gate means addition. Correct? You know, right? That 1, 0, 1, 1, 1, 1. Addition. 0 plus 1 is 1. 1 plus 0 is 1. 1, 1, it is 1. Logical expression, Y is equal to, output is equal to A plus B. Logical expressions, Y is equal to A plus B. In analog circuit, you are giving a battery and you have a 2 switch here like this, and this is connected with a bulb. This is A and B, and this is Y. Digital circuit, which means using diode. First one, second one, connected, and resistor, ground, R. This is called Y, this is called A, and this is called B. Finished? We'll see OR gate. OR means addition. Okay, so symbol, this is a curved line and this is like a triangle. Y is equal to a plus b. Truth table. 0 plus 0 is 0, 0 1 is 1, 1 0 is 1, 1 1 is 1. 1 plus 1 in binary it is 1. Okay, so logical expression y is equal to a plus b. This is an analog circuit. Analog circuit means circuit using normal switch. Now if you see, you will give these truth table into the circuit. Now A and B, 0 0 means open circuit. If both are opened, any current will flows to the Y bulb, no current will flow. 0 comma 1, 0 means A is opened, B is closed. Any current will flow? Yes, current will flow, bulb will glow. So 1. Next 1 0. A is closed, B is open, current will flow. Yes, bulb will glow. 1 1. Both are closed, current will glow, current will flow, bulb will glow. So that is correct. Next one is digital circuit. This is most important. This is the real question where Neet falls. You are giving 0 0. Once you are giving 0 here, once you are giving 0 here, 0 means the meaning is like 0. Once you see 0, you have to assume it is grounded. That's all. Don't draw it in the book. Now this is for 0 0 condition. So this is 0 and this area is also 0. Both sides 0 0. Diode forward bias or reverse bias, we cannot say. Diode will not work. To work, diode is in forward bias and the E voltage higher. This voltage is not higher, right? E side is 0 and E side is 0. So diode is in what condition? Diode will not work, which means it is similar to a reverse bias condition. So Y is the output. Output means the current flowing here and current into resistance. I into R is equal to Y. Now both are grounded, so Y equal to 0. Both are grounded and Y equal to 0. Next one 0 comma 1. 0 comma 1 means which is grounded? A grounded. B what voltage I will give? 5 volt. Okay, 1 means 5 volt on any meaning. 1 is 5 volt standard. So it is 0. So E side is 0. So this diode will not work. But here 5 volt. E side how much is the voltage? This is connected to ground. So here is a higher voltage. So this diode is forward bias. So current will flow and coming and going to ground. So what should I will get? I into R. Voltage. Voltage means Y. So I got output. So that means I got 1. Okay, I got 1. Then again we'll go to the next one. Next one is what? Next one is 1 0. 1 means what? This is 1. This is 5 volt. Other one is 0. So it's grounded. Which one will work? A will work. So the current will flow here and current will come to ground. So I into R you will get output. Next one is what? Both are 5 volt. So current will come here, current will come here, both current is joining here and going to resistance. So I will get I into R, I will get output voltage. That's all. Understood? OR gate realization using diode. Okay. OR gate realizations using diode. So this you have to understand. Whenever if you see 0, 0 means 0 voltage, ground. Next gate, AND gate. Second one AND, A and D, and A. Symbol of AND gate. A, comma, B, and this is Y. A, B, Y, 0, 0, 0, 0, 1, 0. A, B means multiplication, AND gate. 1, 0, 0, 1 into 0 is 0, 1 into 1 is 1. So Y is equal to A dot B. An analog circuit, one switch and then second switch, A and B, connected to a battery and connected with a bulb. Digital circuit. the ground alla, this side ground alla to. This is ground. The ground on. Here we have given voltage. So resistance are രണ്ട് diode. This is A and B. Okay, so AND gate, two input A and B. Y is equal to A into B, multiplication. 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1 is 1, multiplications. So two switches will be there. So you can see 1 into 1 means both are closed. When both are closed, only bulb will glow. Any one closed means no use, others one will be open, current will not flow. So 0 into 0, 0, 0, 1, 0, 1, 0 is 0. 0 means opened, 1 is closed. So this is very simple, right? Both are closed, only bulb will glow. Next we look to here, digital circuits. So you are giving 0 and 0. You are giving 0 and 0 means what you are doing? You are ground here, you are ground here. Okay, what will happen to the transistor? What is the output of the transistor will be here? Because this is 0, okay, here nothing, here just a wire only, just a voltage only. Okay, so here at this point of line, there is no current flow from here or anywhere. Okay, yeah? So what will happen means here what I am going to do means I am going to take output will be here. I am going to take output. I am going to take output. Output I am going to take means what? Output means this point with respect to ground. Here I am taking output means output with respect to ground. Here output with respect to ground. E ground alla. Between this ground one voltage will be there. So I cannot take here. I have to assume this is with respect to ground. So this voltage with respect to ground. Ground means I have two paths. One path is this one is ground. Correct? This one is a ground. From this point to ground, there should not be any other connections. There should not be any other connections. Now this diode is forward biased or reverse biased. See here high voltage will be there. How much is the voltage? Here this voltage connector means 5 volt will be here. So this 5 volt will come here also. Small loss will be here, but 5 volt will get it. So this 5 forward biased. This also forward biased. So what will happen? Say what will happen means from here the current which are going directly into ground, current which are going directly into ground. The currents which are going here, the currents which are going here, but there is no current flow towards output side. Okay, if there is no current flow towards output side, because here is a high resistance path. Whenever come here, whenever it will look here there is no connection. So it is a kind of open circuit high resistance. But when it's look here, it is just like a short circuited. Correct? It is a short circuit. So current will always choose the low resistance path. So immediately current will go through this one, current will go through this one, and it will get grounded. So output will be equal to 0. Never by heart this one. Second one, we'll see 0 and 1. 0 and 1 means this is 0 and this is 1. This is 1 means here I am giving how much voltage? 5 volt. Here already 5 will be here. Here already 5 will be here. So this diode will not work. Positive side high voltage vana, negative side low voltage vana. So this diode will not work. But this diode will work. Because here 5, here 0. So what will happen? The current from here will go to ground. So output is again equal to 0. Next, both will be 1 1. Both will be 1 1 means here it is equal to 5 volt. This transistor is off. This transistor is off. This current has no way to go here. So what will happen? This will be here itself. So output is equal to 1. Understood? Then write the next one. Third one. NOT gate. Third one, NOT gate. Digital circuit is the most important one. Okay. Name, not, symbol, you know, right? Not gate. Truth table, only one input, one output, A and Y. A is 0, B is 1, 1, 0. Logical expression Y is equal to A bar. I'll come to analog circuit. Digital circuit I have to do first. Okay, not gate means if you are giving 1, if you are giving 1, you will get 0. Now we'll assume this is a switch. Okay, if the switch is closed means 1, you are giving 1. If the switch is closed, what is the voltage between these 2 points? It's a wire, 0. Voltage 0 means bulb will glow? No. So means 1 means closed, output is no glowing means 0. Now you are giving 0 means switch is opened, you will get the same voltage here, bulb will glow. So 0 means switch open, bulb will glow. Next one, digital circuit is a transistor. Now you are giving input voltage here. If you are giving input voltage, IB will be there. Because of the IB current, transistor is on or off? If you are giving input voltage, base current will be there. Because of the base current, transistor is on. If transistor is on means you can consider this is like a switch. Okay, you can consider this is like a switch. So transistor is on means switch is on. Okay, now I am replacing this with another diagram. For example, RC. This is a switch like this one, for example, and here I am taking output. Correct? Transistor is replaced with a switch. Now you told me switch is on whenever you are giving 1. Okay, so whenever you are giving 1, transistor is V in is equal, I am doing the second row, V in equal to 1, IB is equal to have a positive value, so transistor is on. Transistor is on means transistor is like this, on. Switch is closed on. So what is output voltage with respect to ground? 0. So 1 you have given, got 0. Next one, 0 you are given. 0 you are giving means 0 will be here. So what is the input current? You are not giving voltage, so you will not get current. So transistor is on or off? Off means transistor is off, not connected. When transistor is off, what will happen? Here we have VCC. Okay, so what is the voltage will be here? VCC minus ICRC. ICRC will lose here, balance you will get it here. Correct? So the output, this voltage is called V out. So what you will get will be here V out equal to VCC minus IC into RC. Okay, you are giving VCC, IC RC is loose here, balance you will get because it is not connected to ground. If it is connected to ground, its voltage equal to 0. So this is not 0, which means it is 1. Understood? Then the next gate, the next one, NOR gate. NOR gate. NOR gate. Okay, 2 input. What is the difference between NOR and OR? NOR means OR plus NOT. Okay, OR in the opposite on NOR. So 0 0 0 1 1 0 1 1. Okay, OR gate in 0 plus 0, what we will get? 0. But here what will get? 0 and 1. 0 plus 1 is OR gate, but in NOR gate what? 0. So this is 0, this is 0. Just listen one moment before drawing the digital circuit. See, this part we already learned. This is what circuit? This area. OR circuit. What is this extra? NOT. So OR is connected with NOT. Okay, simple way. OR is connected. This part is OR. We already know, right? This is OR. This is connected with NOT. So OR plus NOT equal to NOR. Now, can you draw for NAND gate? NAND gate you can draw. Then the logical expressions. What is the logical expression? Y is equal to A plus B whole bar. A plus B whole bar. A plus B சொல்லும்போது அது OR gate and whole bar எடுத்தனா and OR NOT. ഈ മൂന്ന് ഗേറ്റിന്റെ ഡിജിറ്റൽ സർക്യൂട്ട് very important. If you learn that digital circuit and analog circuit, it is easy for you to draw for NOR and NAND. NAND gate. Analog circuit correct? NAND gate? Correct. Because if both are opened, Okay, or any one opened, bulb will glow. If both are closed means 1 1. Both are closed means 1 1. If both are closed means short circuited. Y equal to 0. No, bulb will not glow, right? Then draw the digital circuit. Hope you have drawn before than me, right? Okay, so how it look like? First, what we have to construct a AND gate. AND gate, how it's look like? Here resistor, here one voltage. This can be taken to upside also. Okay, but voltage should be there. Then this is connected what? The balance thing, resistor. The balance resistor. This will give us an input, and this is an emitter, and this is connected, and this is RC, and then VCC, and this is output. So this is an AND part. This many part, and this part is not part. Not part. Okay. Okay. Two more things will be there. For that, analog circuit and digital circuit is not required, but all other things are required. Okay. Okay. XOR gate. A, B, Y. A, B, Y. 0 0 0 0 1 1 1 0 1 1 1 0. Y is equal to AB bar plus A bar B, which is equal to A XOR B. XOR gate. XOR gate. XOR gate. XOR. A B bar plus A bar B. ഈ XOR ഗേറ്റിന് ഒരു സ്പെഷ്യാലിറ്റി ഉണ്ട്. വാട്ട് ഇസ് ദ സ്പെഷ്യാലിറ്റി മീൻസ് whenever odd multiples of 1 comes, then output is 1. How many 1 will be here in the first row? 0. Okay, so it is 0 only. How many 1 will be there in the second row? 1 1. So output is 1. How many 1 will be there in the first row? 1. Third row. Then how many 1s will be there in the second row? 2. Even number of 1s will come, output is 0. Suppose there is one questions will be there, and here JE advanced. The input of an XOR gate are A, B, C, D. Input of an XOR gate is A, B, C, D. Which of the following output yields 1? Okay, 4 combinations ഉണ്ടായിരുന്നു. A, B, C, D എന്നാണ് 4 options. 0 1 1 0, 0 1 0 0, 0 1 1 no 1 1, all are 1. 1 0 0 1. Which one will yield the output is equal to 1? Which one? Option B, because this row will contain odd number of ones. Here 2 ones, here 4 ones, here also 2 ones. So this is the right answer. One shot you can answer. 4 mark in the question, but nothing there. Advanced examinations. Next one, XNOR gate. XNOR gate. Okay, just to write to that point also. If odd number of ones, here please write, if odd number of ones, if odd number of ones comes as the input to the XOR gate, then only output is 0. Then only output is equal to 1. then only output is equal to 1. All other cases output equal to 0. The last one, XNOR gate. XNOR, XNOR or NOR, XNOR. A, B, Y, near opposite truth table, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1. Logical expression Y is equal to A bar, B bar plus AB, or we'll say A X or B whole bar, or we'll say A X nor B, like this, 3 notations. Okay, X or B. XNOR XOR plus not XOR. Next, De Morgan's theorem. De Morgan's theorem. De Morgan's theorem. What is the De Morgan's theorem statement? There are 2 statements will be. One, A plus B. Then the whole bar. The whole bar equal to the split A bar. This rule. 2 rules are nothing else. Bar is equal to A bar plus the next heading not. A plus B whole bar equal to A bar dot B bar. A dot B whole bar, then a bar split A bar plus B bar. Next write as a note. NAND and NOR gate. NAND and NOR gates are called universal gates. Are called universal gates. Less chance to ask. Next one. NOR gates are called universal gates. Next one. A single NAND gate. A single NAND gate or a single NOR gate is equal to NOT gate. Let's see some examples. As an example, I am giving one inputs like this, NAND gate. Okay, so A is the input I am giving to the gate. So A is split as 2, A and A. What is the output? The general equation is Y is equal to AB whole bar. Equation for a NAND gate. Now A and B both are same here. So what I can written as A into A whole bar. What is A into A? 1 into 1, 1. 0 into 0, 0. So it is same thing. A into A is A. So this is equal to A bar. This is similar to a NOT gate. Okay. Similarly, the next one for a NOR gate. So A. So I know Y is equal to A plus B whole bar. This is equal to A plus A whole bar. What is A plus A? 1 plus 1, 1. 0 plus 0, 0. Both are equal, right? A, 0, 0 or 1, 1. So this become A. So A bar. Then the continuation of this one. A single NAND gate or NOR gate is equal to a NOT gate. Next one, A plus A bar is equal to what? A plus A bar. Suppose you assume A is equal to, then A bar will come what? 1. 0 plus 1 is what? 1. Suppose you assume A is equal to 1. So what is 0 plus 0 is 1. So always 1. Okay. Second one, A dot A. If A is 0, A bar is 1. So 0 into 1 is 0. If A is 1, A bar is 0. So 1 into 0 is, okay. Next one, 1 plus any number you add, what you will get? 1. 1 plus A is equal to, okay, the problem solve we will use it times. That's all. The next heading, optical devices. Optical devices. Optical devices. More optical devices we are going to learn. What are these? LED, photodiode, solar cell. So first one, LED, light emitting diode. Very simple, just 2 points, nothing else. For Neet point of view, LED, light emitting diode. Name itself representing. Correct? Light emitting diode. Diode will emit light. How it is possible? Which means here have a diode N and P. Okay, is it a diode? The diode in the atom top or glass cover. Normally you have seen LED, right? Out a glass cover. A glass cover, what will happen means if you are giving some energy. For example, I am assuming H nu. The light energy definitely what is available will be here. We have a barrier potential. Okay, barrier potentials will give rise to what? An energy. Potential is equal to an energy, right? QV. If you have a potential, you have an energy. What is this energy will be called? Delta Eg, energy. Energy, it is a barrier, right? Valence band, conduction band in the are different. So if you are giving a light energy to improve the conductance, H nu should be equal, greater than delta Eg. Okay, then what will happen? The electron already these electrons are moved to p side, already moved to n side, then it is stopped after some time. Fusion it is stopped, then depletion region is formed here. Next I am giving light energy. If I am giving light energy which is great, again the movement of what will start? Electrons from to p side will start, from p side to n side will start. Then what will happen? Recombination will happen. This recombination the energy. That energy is also called as what energy? Light energy. Light energy. So the basic principle what is emitting diode is recombination of the charge carriers releasing the light energy in one shot. So below, right, light emitting diode LED. LED is working in forward bias condition. LED is working in forward bias condition. LED is working in forward bias condition. LED is working in forward bias. Just a sentence is enough. They will not ask anything else. He will be here. Okay, working in forward bias condition. Whenever an external energy given to the diode, external energy, light avam, thermal energy avam, battery avam, anything. Whenever an external energy given to the diode, the electrons from n side move to p side, electrons from N side move to P side and holes from P side moves to N side. Moves to N side. Next point. This leads to recombination. This leads to recombination of charge carriers. This leads to recombination of the charge carriers. Recombine energy release. Okay. So this will releases the light energy. This will releases the light energy. Okay, now recombinations badala, this is releasing the light energy. The light energy is depends upon what is the chemistry of that diode. Chemistry means what type of semiconductor is used, whether it is gallium arsenic, whether it is silicon, whether it is germanium. So different material chemistry lab also you have seen, right? Sulfate is like a precipitate. Correct? It's like a precipitate, it's like a powder. So similarly potassium will be there, it's a different color. So every chemical compound will have a different color. So based upon that chemistry, the color of LED will be changes. So below, right, based upon the chemical composition of the semiconductor, 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 light emitted by the diode, have different wavelength, which means different color. Different wavelength, which means different color. Next one, photodiode. Next one, photodiode. Just read it, just leave it. Okay, some theoretical questions may come. Photodiode. What is photodiode? Photodiode, below, right? Photodiode is working in reverse bias condition. So below, right, photodiode is working in reverse bias condition. Photo is working in reverse bias condition. Draw the diagram for N type. Okay, photodiode, there is a window. Outside there is one glass material will be there. A glass material it can able to accept the light energy. Once the light energy will be accepted, what will happen? Previously I told, if that is greater than the band gap or forbidden energy gap, electrons and holes are started to move. Electrons are started to move, which means recombines. But here, in additionally, what is their extra connected? A battery is connected in reverse bias. So whenever these electrons and holes are started to move, what will happen means here negative. So P type, all the holes are trying to move towards the P side and all the electrons are trying to move to this side. and but this is a majority carrier movement, but there is as well as what is there, minority carriers. Minority carriers means electrons. Electrons will be moving, repelled by the battery, moving towards inside. Here holes will be there, holes are repelled by the positive and move towards this one. So there is a minority current will be there. That is the representation of minority current. Whenever your voltage will be changes, there is a different value of minority current, I3, I2, I1. Different values of minority current. So this minority current will give rise to the current, and this current is also called photo current. Photodiode another photo current. Okay, only difference is extra negative is connected, but here the majority working is due to minority carriers. So draw the graph, then we'll write a couple of sentences. These are some devices. Okay, below, right? For working in reverse bias condition, we have written up. Okay, is working in reverse bias conditions. Light of sufficient length. When light of sufficient wavelength falls on the window, electrons and holes are getting separated. Electrons and holes are getting separated by the electrons are getting separated by the battery, and majority carriers are started to move across the junction, and majority carriers are started to move across the junction, which give rise to photodiode current across the junction, which leads to the photo current, which leads to photo current. Majority carriers are separated means majority carriers are moving here. Majority carriers are moving here, but minority carriers will cross the junction, and it leads to photodiode current. Next one, solar cell. This graph important aanu. Rest of things are not much. Next one, solar cell. Solar cell straightforward again. The solar cell is working at what time? Night solar work ചെയ്യുന്നത്, correct അല്ലേ? Morning it will store the solar energy, night it is converting to electrical energy. അതല്ലേ solar cellന്റെ main purpose. Okay, solar cellum photodiode മാതിരിതാ, but there is only one difference. There is no voltage we are not giving to the diode. കേട്ടോ, solar cell we are not giving any voltage. Solar cell is a panel. അതാണ്. So from there we are taking the current. So only difference between these two, in a solar cell we don't have any voltage. So solar cell is just a PN junction diode. PN junction diode, solar cell. ഇതിക്ക് മേലെ ഒരു ഗ്ലാസ് ടോപ്പ് ഉണ്ടായിരിക്കും. ഗ്ലാസ് ടോപ്പ് ഇങ്ങനെ ഒരു ബാക്ക് എൻഡ് കണക്ടൻസ് ഉള്ള ബാക്ക് എൻഡ്, അതൊരു ജസ്റ്റ് അതിൻ്റെ പ്ലേസിംഗ് ആണ്. ദിസ് ഗ്ലാസ് ടോപ്പ് അറ്റ്ലീസ്റ്റ് യു ഹാവ് സീൻ, റൈറ്റ്? ഗ്ലാസ് ടോപ്പ്. ദെൻ അതിൻ്റെ മിഡിൽ ആകുമ്പോൾ ഒരു ബ്ലൂ കളർ ആയിരിക്കും. ആ ബ്ലൂ കളറിന് ഒരു പ്ലേറ്റ് ഉണ്ടാവും, അതാണ് ഒരു ബാക്ക് എൻഡ് പ്ലേറ്റ്. അതാണ് സോളാർ സെൽ. സോളാർ സെല്ലിന് ഉള്ളിൽ ഇരിക്കുന്നത് എല്ലാമേ ഡയോഡാണ്. ഐ ടെൽ യു വാട്ട് ഇറ്റ് ഈസ് ഹാപ്പനിങ്. ഈ സോളാർ സെല്ലിലെ മോർണിംഗ് വാട്ട് ഈസ് കമ്മിങ് വിൽ ബി ഓവർ ഹീറ്റിംഗ് വിൽ ബി ഹിയർ. സൺലൈറ്റ്. കേട്ടോ, മോർണിംഗ് സൺലൈറ്റ്സ് ആർ കമ്മിങ്. സോ വെൻ സൺലൈറ്റ്സ് ആർ കമ്മിങ്, what will happen? Okay, suppose assume this is a solar cell. I have connected with a bulb. Okay, morning time my bulb is switched off, for example. Okay, morning time bulb is switched off. So whenever the light energy falls over will be here. This bulb is switch off means what is the meaning of that one? It is open circuit. Correct. So whenever light is falling will be here. Here what is already available? Depletion region, energy gap. If my light is sufficient, means more light, noon time nalla sunlight ആയിരിക്കും. അപ്പോൾ sunlight വരുന്ന ടൈമിൽ what will happen? That energy H nu, light energy is higher than the energy gap. So what will happen? Electrons and holes will be here. Here more majority carriers holes will be here. Here majority carriers electrons will be there. What will happen? It will try to move both sides. It will try to move, which means it will try to move means it cannot move outside the circuit because it is open circuit. This will be undergoing random motion. Random motion because it is excited, which means it got energy. Whenever night time, so this process will continue always within the solar cell. So this is a voltage which is available when the circuit is open. So a voltage which is available will be here, a stored voltage, that is called open circuit voltage, VOC, open circuit voltage. Okay, whenever night time you switch on the bulb, so you closed it, what will happen? The voltage which is stored will be here, start to discharge in terms of called what? Current. That current is short circuit current. When it increases, means that what? The voltage available within the diode which is stored the voltage at which time? Morning time. Daytime it is voltage. That you are using the form of current. Understood? This is happening in solar cell. Now if you plot a graph for solar cell, voltage versus current axis. So this is a voltage axis, very very important, and this is a current axis. So morning time it is stored with what is called open circuit voltage. Open circuit means it is not connected anywhere. Night time when you are connected with a bulb, what will happen? Voltage is reducing, but current what will happen? Increases. So the graph will come like this one. The current is increases, voltage is reducing, and this current is called ISC, short circuit current. Short circuit current. Short circuit current. This is called open circuit voltage. Very very important, this graph. Very important. Open circuit voltage and short circuit current. So the diagram and the graph it comes on which quadrant? Fourth quadrant. Current is not negative. Current is not negative. Current direction is importance. Current direction, there is no significance. If electrons in the movement in their direction, current direction is opposite. Left. Diode connected. Now I connected PN. So what is the final current direction? Final current I equal to IE plus IH. Okay, what is IE? Electrons are moving in this direction. So current is in this direction, electronic current. Holes are moving in this direction. So IH is in this direction. But if you take NP, it is opposite. Okay, if you are taking in NP order, this will be give rise to in opposite direction. Suppose in normal cases, once you are describing about the diode, will always start with NP like this. And NP and transistor are common use. NP diodes are common use. We will always read from left to right, NP. NP the electrons are moving like this one. Currents are moving what direction? IE. Holes are moving like this one. So what is IH? So left, it is down, nothing else. Okay, you don't want to bother about the directions, but this is fourth. And that NP is convention. PN is the reverse. Okay, by standard convention, NP is fourth quadrant. So below right, open circuit voltage is the maximum voltage stored at the open circuit voltage is the maximum voltage stored at the solar cell. It discharges the current. which is called short circuit current ISC. Which is called ISC, which is called ISC, short circuit current. Graph is in the fourth quadrant by convention. Graph is in the fourth quadrant by convention. By convention NAP order graph fourth quadrant. Okay, we'll take a break, then we'll see some questions. Okay, first one, number one. Okay, if you learn theory very well, tak will answer. Okay, number one. Change of 8 milliampere in the emitter current bring a change of 7 milliampere in collector current. Value of the parameter alpha and beta. Change of emitter current, which means what? Delta IE, that's all. Emitter current, right? So it is 8 milliampere. Bring a change of 7 milliampere in collector current. IC equal to 7.9 milliampere. Value of the parameter alpha and beta. What is alpha? IC by IE. In terms of change, we can write as delta IC by delta IE. So 7.9 divided by 8. How much will come? 0. If you look into the option itself, we can see 9 0 varade, 7 9 varade. Alpha is the first parameter. Okay, so how much will come? 0.99. 0.99. Calculation here, that's all. Okay, you can do the calculation. Next, beta. 0.99 divided by 0.01. How much is coming beta? 99. Alpha how much? Alpha exact value alpha correct 79 divided by 8 into 10 power minus 1. How much will come? Exactly. Alpha exactly correct. First alpha value 9996. 0.97 only. Okay, let me give. We'll see. Okay, if alpha is 0.97, then what? 0.97 divided by 0.03. What this is coming? That is called a beta, right? So 97 where are they? 99 0.99. Okay. Then what should go? 99. How much is coming? 90? 99. Is any options are matching? No. Then just keep it 0.99 and 0.99. Totally how many questions? 45 questions. Okay. Okay. 17 and 8 9. The correct 999 the correct value 987. Like for example 0.987 987 because 79 by 8 9 8 88 64 9875. So which is this is approximately equal to 0.99. Okay, so if you're taking the 0. For example divided by 1 0.98 exact 0.79 വരും. 0.79 അല്ല, ബീറ്റ വരുമ്പോൾ 79 വരും. 79. സോ 0.99 ആൻഡ് 79. ഓപ്ഷൻ ഡി വരും ആൻസർ. ഓപ്ഷൻ ഡി. പ്രിസൈസ് കാൽക്കുലേറ്റ് ചെയ്യണം, അவ்வளோதான் ഡിഫറൻസ്, വേറെ ഒന്നുമില്ല. ഓക്കെ, പ്രിസൈസ് ആയിട്ട് ഇതിന്റെ വാല്യൂ വരുന്നത് 987 ആണ്. യു കൻ അപ്രോക്സിമേറ്റ് ഇറ്റ് 99. ദർ ഇസ് നത്തിങ് റോങ്. ബട്ട് വെൻ യു ആർ സബ്സ്റ്റിറ്റ്യൂട്ടിംഗ് ഹിയർ, alpha value should be less than or equal to 1. 1 0 kadakka. Okay, so option D is the right for this one, question number 1. Okay, let's go to next one, question number 2. A pure semiconductor has equal electron and hole concentrations of 10 power 6 meter cube ആണ്, per meter cube ആണ്, per meter cube. So that is called what? Intrinsic concentration, correct? Intrinsic concentration is 10 power 16. Doping by indium increases the number of hole concentration, NH2, 5 into 10 power 22 per meter cube എന്നുള്ളതാണ്. അത് m raised to p എന്നായതാണ്, ടൈപ്പോ മിസ്റ്റേക്ക് ആണ്. Then the value of number of electrons doped in the semiconductors will be, how to find out Ne? Ne into NH equal to Ni square. So Ne into NH, 5 into 10 power 22 into Ni square, 10 power 32. So what you are getting for Ne? 2 into 2 into power 9 per meter cube. So this is called Ne, number of electrons in number of electrons. Okay, number of electrons. So second one over, clear? This is similar to the question what we have done in the notebook, right? Okay. Okay, finished up. Third question. Third question is a theoretical question. For an LED to emit the light in the visible region of electromagnetic spectrum, it should have an energy gap. How to find out energy gap? Energy gap has to be find out. Eg is equal to hc by lambda. Appo lambda യുടെ വാല്യൂ എவ்வளவு വരണം? വിസിബിൾ ലൈറ്റിന്റെ റേഞ്ച് എவ்வளவு? 400 nanometer to 700 nanometer. This you have to substitute. If you substitute 400 nanometer, you will get some value. But I told a shortcut for this one, right? 12400. Can you solve 12400 by what I told will be here? Angstrom. So you have to convert 400 nanometer to angstrom means what? 4000 angstrom. Correct? 4000 angstrom. So lambda should be in 4000 angstrom. This angstrom. So you will get an energy. Nanometer to how much will come? 700 nanometer. So how much it's coming for 400 nanometer? Next one is what? 700 nanometer also we have to find, right? That is the range. So 700 means 7000 angstrom. How much it's coming for this? How much it is coming for this? First one, how much is the value? 3.1. What is the value of the first one? 3.1. Okay. Second one? 1.7. 6 point something or 7. So which one will match us with this option? Option D. So option D is the right answer. Good. Fourth question. Fourth question. What is the fourth question? A common emitter amplifier has a voltage gain. Input impedance RB is 100. They are asking about power gain. So how to find out power gain AP in terms of voltage gain? AP is equal to AV into, I told one equation, right? AV into beta, but there is no beta will be. So how I can find out voltage gain with all this thing? How I can find the current gain? But beta we cannot use, it will be here, right? Without beta, how I can find it? With respect to the voltage gain which is given and resistance is given, can you think about that? Power gain kanduttina. Power gain means what? Output power by input by. So we have written beta square into RC by RB, or beta into AV we are also written. So there is no beta is not given in the question. So what should we do? Logic. Listen. What is voltage gain? In terms of beta. Beta in RC by RB. From here, beta. Then you can substitute there, right? That's all. Then I have spark or last time, the spark, nothing else. So this one is 50 is equal to beta. I don't know. I have to R. We run to 100. Is 200. 200 RC. So RC by RB is 2. Correct. So beta is how much? Beta equal to 25. Now you can substitute here 50 into 25. How much will come? That is there in the option? Yes, option B. The correct type is sparking. Nothing else. This will come through practice only, nothing else. Fifth one. Which logic gates with input A and B perform the same operation as that is performed by the following OR gate? Analog circuits are given, right? This is matches with the OR gate. Fifth B box. Fifth B box OR gate. Sixth one. In an unbiased PN junction, hole diffuses from the P region to N region because of, read the four option: potential difference across the PN junction, attraction free electrons of N region, higher hole concentration in the P region than that in the N region, higher concentration of electrons in the N region than that in the P region. Question is, holes are diffusers from, diffusion is due to difference in concentration, higher concentration to lower concentration. So what option will match? C, holes from P regions to N regions. Seventh. So sixth answer is C. Sixth C. Seventh. A silicon diode has a threshold voltage 0.7 voltage. If an input voltage 2 sin pi t is applied to half-wave rectifier circuit using diode, rectifier output has a peak value of, which means we are, what is the circuit? Half-wave rectifier. Diode will have a threshold voltage 0.7 volts. So this is a non-ideal diode. Okay, ideal diode means it is 0. So how much I am giving? 2 sin pi t. Now here I am getting what called output. Okay, peak voltage means you don't want to, this is called the peak. So you are giving by the diode 0.7. What you will get it output? 2 minus 0.7, 1.3 volt. This is the peak voltage. Okay. 8. Current gain of a transistor working in common base amplifier. Common base amplifier like current gain alpha, beta or gamma. Common base alpha. Okay. So alpha equal to IC by IE. Alpha in common base, right? Current gain of a transistor working common base amplifier is 0.96. So 0.96. Emitter current is 7.2 milliampere. 7.2 milliampere. Question is what? Base current. Base current is what? So from this, what I can find out? IC I can find. Once I get IC, how should I find out IB? Substitute IE is equal to IC plus IB. Or you can use beta equal to alpha by 1 minus alpha. Can you tell me what is the value of? So easy method, from this one we can find the value of IC. So we'll write IC is equal to alpha into IE. Alpha is how much? 0.96 into 7.2 milliampere. So IC will get in milliampere. How much is the I value of IC? Six point 6.91 milliampere. Okay, next I know IE 7.2 minus how much? 0.2. What is matches with that options? 0.29 milliampere. 0.29. So option A. So option A is the right answer. Easy only, right? When the calculations are there, that is part and part. Nothing to do. No pain, no gain. Okay. Ninth one. Up to 8th it is completed, huh? Ninth one, I think the timing value is missing there. Okay, we'll see. In an NPN transistor, 10 power 10 electrons enters the emitter in 10 power, I don't know what is the time, I think it is 10 power minus 6, I guess, minus 6 second. Okay, we'll see. We'll substitute minus 6 and say some time it's given. So 10 power minus 6, you can make it as 10 power minus 6. We'll see what we are getting answer. I didn't remember the value. So in an NPN transistor, 10 power 10 electrons enters the region in 10 power minus 6 second. Okay, so fine. 4% of electrons are lost in the base. The current transfer ratio. Current transfer ratio means what? IC by IE. Output current by input current. So, how to find out input current? Input current means what? Input current is coming from where? Emitter. Emitter is emitting how many electrons? Power 10. So, how to find out current? Current is equal to charge by time. So, Q is equal to NE by time. So, N is a number, 10 power 10. E, 1.6 into 10 power of minus 19 divided by time, 10 power minus 6. Okay. So, this will solve it. So, 1.6 into 10 power minus 3. I the value. 1.6 10 power minus 6. 4% of the electrons are lost. So how much electron will enter into the collector regions? Balance, right? Yeah. Number of electrons 10 power 10 electrons from emitter. Okay. So 4% loss. 4, what is the balance? 96%. So 96% means 96 by 100 into 10 power 10 electrons in collector. 10 power 10 electrons in collector. Correct. So we know number of electrons in the collector. So how to find out the collector current? IC is again NE by here 96 by 100 into 10 power 1.6 into 19 divided by time. How much? 10 power minus 6. Same time in minus 6. A ratio, how much will come? Everything will get cancelled, right? So how much will come? 0.96. Okay. So I think whatever we taken is the time is correct. Whatever time if you take, anyway it will cancel. That's the logic, nothing else. Okay. So what is the only difference we have done? To find out IE, number of electrons are given. NE, Q is equal to NE by T we are used. Okay. Up to 9 question. Any doubt? Any questions you still didn't understand? 1 to 9. Straightforward only, right? There are no new things. All of the things what we have learned only. 10th one. What is the 10th one speed? Assuming that silicon diode having a resistance of 20 ohm, diode will have a resistance 20 ohm, current through the diode is knee voltage is 0.7. How to draw? Voltage is given. Okay, so this is a circuit is given to you. Diode, so no resistance over here. Diode. Okay, so and we have how much is the resistance? And here one voltage is given 2 volt. Okay, we can do diode will have a knee voltage, diode will have a resistor. So I am going to replace the diode. So earlier here it is positive, ground is negative. Here we have a ground. So between these two we have 2 volt. That's the meaning of this one. So this is connected, this is replaced and redrawing. Next, diode with 2 things. One is resistor, one is voltage. So diode resistance, I am putting as RD. How much is the diode resistance? 20 resistance. and diode has a voltage, knee voltage. So diode is replaced with a voltages of 0.7 voltage. Then we have the existing 180 ohm things. This is the connector diagram. What is the question is asking? Current through the diode. So current through the diode means current here. What we will do? Which law will apply? KVL. So we are using this loop. So tell me the voltage from 2 is the supplied voltage which are used by who and all it is using. 2 is the voltage you are giving. It is used by RD. So I into RD. Correct. Then 0.7. Okay. Then so we'll substitute 2 into I into RD is how much? 20 plus 0.7 plus I into 180. Tell me the value. Balance. Steps lead to you. 6.5. So I equal to 6.5 milliampere. For diode, they told two things. Resistance will be there, voltage will be there. So both are replaced. Sometimes they will tell only resistance. So replace only resistance. Sometimes they told only voltage, no resistance. Depends upon the question. So I hope you got it till 10th. We are going to 11th. 11th is what? Transfer characteristics output versus input of a base biased transistor in CE configuration is shown in the figure. For using the transistor as a switch, it is used in both region 1 and 3. 1 is what region? Cutoff, off state. 3 is saturation region. So B, 11th B. So 12th. A half-wave rectifier is being used to rectify an alternating voltage of frequency 50 Hz. Number of pulses rectified, current obtained in 1 second. Yeah? I am giving a signal. I am giving a signal of what frequency? Like this I am giving a signal, right? 50 Hz. 50 Hz means what? Number of cycles per second. One second, how much cycles? 50 cycles. Now if you are taking the output of a rectifier, what you will get? You will get like this one. Output equal to 25 Hz. 25 Hz. If the same question is asking us a full wave rectifier, 50 itself will remain same. Okay, fine. We'll go to the 13th question. So 12th answer B. 13th, a diode having a potential difference of 0.5 volt across its junction, which does not depend on current. He is series with a resistance of 20 ohm across a source. If 0.1 ampere current passes through the resistance, then what is the voltage of the source? Okay, so statement is given, we have to construct a circuit diagram. Yes, a diode having a potential difference of 0.5 volt. So we'll draw a diode for example, and this will have a voltages of 0.5 volt. Does not depend on current. It is connected in series with a resistance of 20 ohm. So it is connected with a resistance of 20 ohm. So okay, what source is this? Anyway, it should be forward biased, right? Only current will flow. What is the current flowing through the circuit? 0.1 ampere. What is this voltage? This V. I know the supplied voltage is used by V is equal to what are the things? 0.5. Diode is used 0.5. 0.5 plus balance is used resistor. So I into R. 0.5 plus I is how much? 0.1. Resistance is how much? 2. Answer is I am giving V voltage and it is used by diode and it's used by resistance. So V equal to 0.5 plus 20 into 0.1. So 2.5. 13th answer is C. Then 14th question. 14th question. In a common emitter amplifier. So 14th. In a common emitter amplifier, current gain is beta. Beta equal to 62. Collector resistance and input resistance are 5 kilo ohm. So RC is equal to 5 kilo ohm and RB is equal to 500 ohm respectively. If the input voltage V in equal to 0.01. So what equation I will use? Voltage gain equations. AV, correct, right? AV is equal to what? Beta into RC by RB. Negative sign will be there, that is representing inversion. So you don't want to take into account. So what is AV? V out by everybody is busy to doing. Okay, tell me the answer then. 62 into divided by RB. 620 into V in 620 into 0.01. 620 into 0.01. 6.2. 6.2. Correct? Correct. 6.2 is the option. 14th B. Options are nice. Okay. 15th. Okay, on doping germanium with a donor atom of density, donor atom means what? Nd is equal to 10 power 7 per meter cube ennullana meaning. Its conductivity, okay, germanium with a donor density, so it is what type of semiconductor? Donor means N type semiconductor, and they are asking about conductivity sigma. For a N type semiconductor is what? Ne mu E capital E, small e into number of electrons into mobility of electrons. Okay, direct substitution. 1.6 into 10 power minus 19 Nd is equal to donor concentration 17. Mobility is given 3800. Everything in centimeters. I am not converting. So how much it is coming? The multiplication of these things. 60.8. Unit enna varum? Mho per centimeter. Ohm inde inverse aanu. Okay, we'll go to the next question. Voltage gain of an amplifier with a 9% negative feedback. With a 9% of negative feedback. Voltage gain without feedback. So voltage gain with the feedback is what? A equal to AV. This is with the feedback. With the feedback. Okay. Without feedback means beta equal to 0. Okay. Feedback is beta. Without feedback, beta equal to 0. So this is with feedback. Without feedback. So we'll write next point. Beta equal to 0, which means without feedback. Without feedback. So A equal to AV. But without feedback, we need to find out what? AV. So with the feedback, voltage gain of an amplifier with a 9% negative feedback is 10. Which means I am writing 9%. So 10 equal to AV divided by 1 plus AV into feedback is how much? 9%. 9% means 9 by 100. If you solve it, then what you have to find out? AV. AV is without feedback. Negative feedback is not an oscillator, some other device. Feedback factor is beta, the same. How much coming? LCM എടുത്തിട്ട് simplify ചെയ്യേണ്ടി വരും. Anything coming? Nothing coming. Okay, we'll see. $100. 100 is there in the option. 90, 10, 100. D, option D. 100. Simplify this, so you will get AV equal to 100. Seventeenth question. So we'll first draw the circuit, then we'll see what we can do. So this is a NOR gate. So this is A and this is B, and this output is connected with this one, and this is another NOR gate. Similarly, this is another NOR gate. Both are combining and go into another NOR gate. This is called Y output. So here we will derive the Boolean expression, Boolean logic expression. Then we will get the truth table. So here A is coming. Correct? NOR gate A and B output. What is available here? A plus B whole bar. Okay. From the top A is coming. So output of this one. All has to add A plus B whole bar. Okay, we'll keep it there. Then we'll come to down. A plus B whole bar is there, then B is coming. So what will coming? A plus B whole bar plus B whole bar. Next we will simplify this one. How we can simplify this? We'll apply De Morgan's law. So plus become multiplication. So A bar, this plus become dot. This bar I am splitting. So A bar, what will coming? A plus B whole bar. A bar dot A plus B whole bar. So what is coming here? A plus B whole bar dot B bar. Correct? This whole bar is splitted into two. So multiplication, addition become multiplication. Now these two are going inside. Again, tell me A bar dot A plus B whole bar. So this is the first input. This is adding with this one. Second one. What is the second one? A plus B. Here this one. A plus B whole bar. A plus B whole bar dot B bar. What happened? Whole bar will come. Then we have to simplify further. A bar dot A plus B whole bar again. Okay, and plus A plus B, not plus, multiplications. So into the second stage, A plus B bar dot B bar, this is whole. Okay, we are splitting again. Once we split this, what will happen? A bar bar, double bar. Correct? Plus, again De Morgan's theorem, multiplication become plus. A plus B double bar. This is multiplied with, here also again, A plus B double bar plus B. A bar, A double bar means what? A plus B and A plus B plus B. What is A plus A? 0 plus 0, 0. A plus A means A. So this is A plus A plus B into, what is coming here? A plus B. So A plus B into A plus B. Binary, not A square plus B square. A plus B into A plus B. You can consider like this letter as X, for example. So X into X. What you will write as? X into A. A plus B into A plus B is nothing but A plus B. So this is what gate? OR gate. OR gate. Addition, right? Finally you are getting A plus B. So OR gate in the truth table where is the answer? Which one? Nothing is matching, huh? Here, here bar will be there. This is splitted. Correct. Sorry. Here one bar will come, right? Once you splitted this one, you will get A bar, A plus B double bar. Here also you will get A plus B double bar. Then this step is wrong. I will correct it. Correct. Yours is correct. XOR gate. Okay, we'll see. We'll see what's coming. So this we can simplify, right? A bar plus A bar multiplied with A plus B. This again you can simplify. A bar into A is what? Z. A bar into A. A bar into A is the A into A bar plus A bar into B. A into A bar is 0 plus A bar B. Top side. Bottom side. A plus B is A plus B double bar. What will come? A plus B into B bar. This we are simplifying. A B bar plus B into B bar. Into B bar is 0. Now these two are going inside. So what is coming? A bar B plus AB bar and add the whole bar. Whole bar. So what's coming? Addition become multiplication. A bar B whole bar dot A B bar this one. So this can be again applied De Morgan's theorem. So A double bar plus B bar with multiplication become plus A bar B. So A plus B. A bar plus 1 for example, then A into A bar, A into A bar, A into B plus A bar B bar 0 plus X NOR gate. Some hard work will be there. Okay. Then what is the X NOR truth table? XOR in the opposite. So what is the, one second, what is the option matching? A. Binary. That is also can do. Got it? Before than Mia. Okay, you given values 0 0 0 1 1 anything that is also corrected. You can give 0 0, then you see what is coming here. Okay, in that way also you can do, or you don't want to do like this. Both method is okay. What he or she told is 0 and 0. Okay, if you are giving 0 and 0, what is the output of XOR gate? Yeah, 0 0 plus 0 will come as 0 in XOR in OR gate. XOR it is 1 1. Now 1 to 0 very much is output. 1 plus 0 0 XOR NOR gate. Here also 1 plus 0. 1 plus 0 is 0. 0 plus 0 is coming. Output is 1. So 0 0 combination output 1. The next combination 0 comma 1. That's truth table 0 comma 1. 0 comma 1 is 1. So it is 0. So 0 is coming here, 1 is coming. 0 plus 1 is 0. This 0 is coming here. So 0 plus 0 is 1. Here 0 and here 1. 0 plus 1 is 1, which is coming outside is 0. So 0 1 ku 0. 1 0 ku it is 0. 1 1 ku 1 1 kodukka. So we'll see 1 1. 1 1. Okay. This 1 1 are going inside. 1 1 0. Now 1 and 0 here. 1 plus 0 is 1 in OR gate XOR NOR opposite. So 1 plus 0 0. 1 is 0. 0 plus 0 is 1. So you get as 1. You can do like that also, or use this one, whatever easy for you. Okay, fine. So answer is A. Either you can substitute 0 comma 0 0 0 1 1 0 1 1 adhe mari kodukka illa idhe mari expression also you can build it. Anything it is fine. Whatever you feel easy, you do that. That's all. This one is a little more easy, right? I feel like this. Okay. Eighteenth question. The conductivity of a germanium at 27 degrees Celsius is 2.13. Conductivity means sigma. Sigma equal to 2.13. Okay, mho per meter. And mobility of electrons and holes mu E 0.38, mu H 0.18. Density of the charge carrier. Density means what? Ne plus NH. Can you find, right? You can find Ne plus NH. So please do that. Ne plus NH has to be find out. Ne plus NH has to be find out. 18th question. What is the intrinsic concentration of formula? Sigma equal to. How will write the formula? Conductivity in the formula? Ne mu E into electronic charge. Correct? Ne into mu E into electronic charge. This is for electron. Holes how much? NH, mu H, the holes charge. Both charges are equal. Okay. So what we need to be find out? Ne plus NH has to be. So sigma is given in the question. Number is given intrinsic concentrations. So Ni is given, right? The question. Mobility. Okay, conductivity at 20 degrees Celsius. Sigma is given. Sigma is 2.13. Mobility 3H. Mobility holes 0.18. The density of the charge carriers. That's all. Intrinsic concentration, right? So this will be the same. So now we'll find out Ne, NH both are same. The density of the charge carriers. So Ni, electronic concentration, electronic charge, whole mobility, whole charge. You can multiply, you have to find out Ni. Ni is the intrinsic concentrations. But what we needed, density of charge carriers means what? Density of charge carrier. Total density means what? Ni is either equal to Ne or equal to NH. So charge carriers means Ne H, which is equal to 2 times of Ni. Intrinsic density of charge carriers. Density of charge carriers Ne plus NH കണ്ടുപിടിക്കേണ്ട ആവശ്യമില്ല. Because Ne plus NH we are using to find out what? അതായത് P type N type ആകുമ്പോഴാണ് Ne plus NH. ഇതിൽ രണ്ടിൻ്റെയും കോൺസെൻട്രേഷൻ ചാർജ് കാരിയേഴ്സിൻ്റെ കോൺസെൻട്രേഷൻ സെയിം ആയിരിക്കും. ഓക്കെ, ഇപ്പോൾ അത് ഫോർ എക്സാമ്പിൾ ഡെൻസിറ്റി ഓഫ് ഇലക്ട്രോണിക് കോൺസെൻട്രേഷൻ അല്ലെങ്കിൽ ഡെൻസിറ്റി ഓഫ് ഹോൾ കോൺസെൻട്രേഷൻ രണ്ടും സെയിം ആയിരിക്കും. സോ ഡെൻസിറ്റി ഓഫ് ചാർജ് കാരിയേഴ്സ് എന്ന് ചൊല്ലുമ്പോൾ ഇലക്ട്രോണിൻ്റെ കോൺസെൻട്രേഷൻ ഇലക്ട്രോൺ ഹോൾ പെയർ കോൺസെൻട്രേഷൻ ചൊല്ലും. അപ്പോൾ ഇലക്ട്രോണിൻ്റെ കോൺസെൻട്രേഷൻ മീൻ ചെയ്യുമ്പോൾ വിച്ച് ഈസ് ഈക്വൽ ഓക്കെ 2Na കണ്ടുപിടിക്കരുത്. 2Na വേണ്ട, ഡെൻസിറ്റി 2Na എടുത്താൽ ആൻസർ വരാതെ മാച്ച് ആവാം. എന്നെ ഏതാ മാച്ച് 2.37 2.3 into 10 power 19 2.3 into 10 power 19. Okay, 19th question. Below has an input waveform A and B. Pick out the output. Can you pick out the output? ഇതേമാതിരി വേവ്ഫോം കൊടുക്കുമ്പോൾ 1 0 0 എന്ന് കൊടുക്കുക. So we'll see the diagram. What is the diagram? Input ഇതേമാതിരി. Okay. So in the question paper itself you can mark. ഇങ്ങനെ കൊടുക്കണം. So ഇതാണ് A. How this is answering I am telling. പോയിട്ട് pulse ഇങ്ങനെ വന്നു. Then pulse. Then it is a pulse like this. So what you have to do means you have to give 1 0 0. Okay. This is representing 1 1. This is representing 0 0. This is representing 0 1. This is representing 1 0. This is representing 1 1. This is representing. Now first you will give 1 1. So what you will get? 1 1. So this is a NOT gate. And both are to a NOT gate. Okay. First you are giving 1 1. So here it is, you will get 0 0. 0 plus 0 in NOR gate. The 1 1 in a corresponding and okay, a high pulse. High pulse with the two option. So moon option A, C, A, D. Okay, we'll see the next one. Next one is what? 0 0. If you are giving 0, what you will get? 1 1. Output is out. First you will get 1 0. What is the third one? 0 1. Okay. So 0 will be there, 1 will be there. 0 and output 1. 1 into the 0. 1 plus 0 is 0. So it will continue in 0 for the next pulse. From here itself we'll get the answer, right? No. I need one more. Okay. So 1 2 3. 1 0. So I'll continue again, one more 0. So answer is D. From here itself. Correct? Simple, right? This is normally the simple stuffs. Question number pure silicon at 500 Kelvin has equal number of electrons and holes. Doping by indium, boron, aluminum, gallium, indium, increases the NH to 4.5. So number of electrons and holes. What is the number of electrons? Number of electron is 1.5 into 10 power of 16. Number of holes due to indium doping. Now the new value will be how much? Increases to 5 into 10 power. Doped semiconductor is off. Doped semiconductor is off. P-type semiconductor, right? There we have to find out the electronic concentration. How to find out? So initially it told Ne and NH is same. How much Ne and NH? 1.5 into 10 power 16. Ni square. Okay, Ni square in the first case is Ne into NH. That is the intrinsic concentrations. So what is the value? We are multiplying these two. 1.5 into 1.5, 2.25 into 10 power of 32. This is the intrinsic Ni square value. Okay, now after doping, I dop it with what? Indium. Now after doping, again Ni square equal to Ne into NH. Electronic number will be the same. What is Ni square? 2.25 into 10 power of 32. This is Ni concentration, Ni square. Electronic configuration, electronic count, we have to find it out. So Ne. But now what is the new hole concentration? 4.5. 4.5 into 10 power of 2. To find out the new value of Ne. 5 into 10 power 9. Correct. So what extra we have find will be here? Ni square we find using the first condition. Then after doping we have to find electronic configuration. Whole configuration changes. So electronic configuration also will get changed. To know that we need Ni square. So this Ni square I get it from the previous statement. Okay. So this is what type of semiconductor? P-type semiconductor with electronic configurations 5 into 10 power 9 meter cube or per meter ആണ് എൻ്റെ എല്ലാം. Then so 20 answer is D. 21. Which of the following statement is incorrect? Resistance of intrinsic semiconductor decreases with increase in temperature. Correct or wrong? Correct, because negative temperature coefficient. Doping of pure silicon with a trivalent impurity gives P-type semiconductor. Correct. Majority carriers in N-type semiconductors are holes. Wrong answer. That's the correct answer. 21C. Okay. 22. Relation between number of free electrons N in a semiconductor with respect to temperature. N into 80 raised to 3 by 2 exponential raised to minus delta Eg by 2 kT. Remember. Okay. So 22 answer is D. So 21C, 22D, 23. If a PN junction diode of depletion region width W, barrier potential is V0, is forward biased, then depletion region width decreases, barrier potential both. What is the answer? Barrier potential decreases or W decreases. Forward biased diode, what will happen? Both the side crunches will happen, right? So the potential, the V0 value is what? Of course you are sure, like W decreases. What will happen to the barrier potential? That also will be decreases. Depletion region width, remember, that is also will be getting decreases. So 23 answer is D. Then the next one. Next one, 24. Circuit has two oppositely connected ideal diodes in parallel. Current flowing through the circuit. Which diode is forward biased? D2 forward biased. Very small one. Okay, so D2 is forward biased. D1 is reversal. So current is not flowing through which resistor? D1 means 3 ohm resistor. So how the circuits will look like? So 12 volt. So here it is 4 ohm and other one is short circuited, so it become 2. Okay, so current equal to 12 divided by 6. 12 divided by 6 means 2 ampere. Answer is option B. 25 it's not required. It was syllabus. Okay, I used the paper some months back. So 25 you can omit. It's deleted from the question. It's not there in the syllabus. HFE, HOE, small signal models. It's not there. So 25 it's not there. 26. A PN junction has a thickness of, or junction thickness, depletion region thickness 10 power minus 6. That option C ആണ്, അത് yes ആണെന്ന്. 10 power minus 6 meter. Okay, 10 power minus 6 meter. 27. Can you read very patiently and tell me the answer? 26, 27. 26th C, 10 power minus 6 meter. 27. Read and understand. Working of it answer. I'll give this as an homework while I'm coming for taking the next chapter. You can tell me. Okay, you have to spend some thought on that one, then you will get the answer. I'll give this as an assignment kind of thing. Easy only, you have to think. Okay, do not keep it as vacant space. Okay, yeah? Next class you have to answer 28. Okay, 27 you think, then we'll see what you are getting the answers. 28. In a PN junction, a square signal of 10 volt is applied as shown. Then the output across RL. Positive voltage is diode forward biased out. Negative voltage is diode cut out. So forward voltage is that only will pass. So what you will get at the output? C means 0 to 5 volt. Upper side mattu available. Lower side will cut. Okay, so 28 answer is C. 27. 28 answer C. 27 left to you. You can think an answer. 29. 29. And when N-type semiconductor is heated, number of electron increases while that of holes decreases. Number of holes increases while that of electron decreases. Number of electrons and holes remains same. This is an intrinsic semiconductor, it's a doped semiconductor. Whenever an N-type semiconductor or P-type, whatever, so if you heat it, number of electron and number of holes will be remains same because it's not going outside. So answer is C. 29 answer is C. Because it has no way to go outside in the simple logic. Okay. 30th. Ratio of electron and hole current in a semiconductor IE by IH is 7 by 4. Ratio of the drift velocities of electron and holes 5 by 4. Ratio of the concentration of electron and holes. I is equal to, what is the formula? NEAVD. Correct? I is equal to NEAVD. So electronic current will be equal to electronic number into charge A into divide left side right side divide IE by IH. Number of holes, electronic charge. Holes in the charge same one. Area. What is IE by IH given? 7 by 4. So we'll substitute 7 by 4 is equal to. What we need to be find out? Number of concentrations, right? So number of concentration has to find out, but drift velocity. Drift velocity is how much? NE by NH. Drift velocity is how much? 5 by 4. 5 by 4. Yeah. 4 and 4. Okay. 7 by 5. The 29 answer. This is 30. The answer is 30. Answer is D. D or B, right? B. 31. 31. Carbon and silicon both have the same lattice structure, having 4 bonding electrons each. However, carbon is an insulator, silicon is an intrinsic semiconductor because see, 4 bonding electrons in case of a carbon lies in the second orbit, whereas case of a silicon they lies in the third orbit. Correct? Carbon electronic configurations and what is carbon? Carbon 6. Carbon 6 is 1s2, 2s2, 2p2. Silicon is Silicon is how much? 6. So silicon is 14. So S2, 2s2, 2p6, 3s2. So this is in the third orbit. Okay. So option is C. 4 bonding electrons of the carbon lies in the second orbit, and whereas for silicon it is lies on the third orbit. Okay. So 31 answer C. അതുകൊണ്ട് higher energy ആയിരിക്കും ഇലക്ട്രോൺസിന് വെളിയെ പോകുന്നത് easy. It is easy to go outside for silicon comparable to carbon. 32. Which of the following represent the forward bias diode? Positive terminal highest voltage ആയിരിക്കണം, negative terminal lowest voltage വരണം. ഏത് ഓപ്ഷൻ ആണ് മാച്ചിങ്? D. D യിൽ പോസിറ്റീവ് ടെർമിനൽ 0, നെഗറ്റീവ് ടെർമിനൽ -2. So D is the correct option. That is the forward biased. Positive terminal more positive, negative more negative. Why not option A is not the answer? -4, -3. The left side adhigam. So it's not the correct. An oscillator is nothing but an amplifier with positive feedback. 33A. 34. Answer it. Current gain in common mode of transistor is 10. Common emitter. So beta equal to 10. Input resistance RB 20 kilo ohm. Load resistance, which means RC. RC is 100 kilo ohm. Power equal to beta square into RC by RB. AP power gain equal to beta square into RC divided by RB. Beta square means 100 into RC by RB. 100 divided by 10. How much will come? I done wrong here. 1 second. Emitter 10 square is 20. Okay, 20. So it become 500. 500 is option B. 35. Input signal given to a common emitter amplifier having a voltage gain of 150. VI equal to 2 cos 15 plus pi by 3. Corresponding output signal will be 300 cos of omega t plus pi by 3. Pi plus pi by 3 4 pi by 3. Which option? C. Option C is the right answer. Okay. This model we have just now written, right? Solve it. Okay. So then 36. To use the transistor as an amplifier. Junction should be forward biased and base collector junction should be reverse biased. That is called active operation. 36A. 37. A piece of copper and another piece of germanium are cooled from room temperature to 77 Kelvin. It is cooled. Resistance. Copper, because copper is a conductor. Copper decreases, germanium increases. Option D. 37D. A DC battery of V volt is connected to a series combination of resistor and an ideal diode D as shown in the figure. Potential difference across R. Potential difference across R. Potential difference across R. DC voltage of 2 volt is V volt is connected in series combination of resistor R. Ideal diode is connected. So drop equal to 0. Something is missing, right? Yes, V original forward as R across R the V the very, because it is parallel circuits. Parallel, same circuit. 2 volt when diode is, it's not 2 volt, it is just V volt. Option A is the right answer. 2V mighty V nag. So 2V instead of 2V. Okay, V volt when the diode is forward biased. Same voltage will be available. 38 A answer A. It is not 2V, it is V volt, because diode forward biased there is drop for an ideal diode. 39. Current gain of a transistor working in common base amplifier, common base alpha equal to 96. 0.2 milliampere. From alpha what you will get? IC divided by IE. IC has to find out. IE is 7.2, alpha is 0.96. So IC is how much? 0.96 into 7.2. IB equal to base current has to find out. What will come? IE minus IC. Already solved it, same model. Okay, so what is coming? 7.2 minus 0.96 into 7.2. Correct line. Okay, you can solve it. Yeah. Same model solved, same value. Okay. So what the answer is coming? 29, right? 0.29. Already solved. Same thing. 29 answer, 39 answer A. 40. In the circuit given below, A and B represent two input, and this is which gate? OR gate. Option D. 40D. 41. The IV characteristics of a PN junction diode is shown below. Approximate dynamic resistance of the PN junction when the forward voltage of 2 volt is applied. Resistance kandupidikkanam. Forward resistance. Forward resistance means what? Ri, or the forward resistance, input resistance. Forward resistance of the diode means what? Delta V divided by delta I. What is the difference? 2.1 minus 2. 0.1. What is the corresponding change? 800 minus 400. 400 milliampere. 400 milliampere means so 2 0 cancels. 5 by 4. How much will come? 1 point. Right? 5 by 4, right? 0.25. 100 per 1000. 100. So 0.1 into 10 power of 3 divided by 400, which is equal to 100. 400, which is equal to 0.25. 42. Circuit is shown logical combination with the states X, Y and Z. X, Y, Z. For the given input P, Q, Rs, all are set to 1. When input P and R changes to 0, P and R changes to 0. With the input Q and S is still 1. Then what is the state of X, Y, Z? Can you tell me? P in a 0 occur. Q in a then R in a 0 occur. Then what is now for X? What is now for Y? And what is now for Z? Draw the circuit first. Draw the diagram first. So this is a gate. This is a NOR gate and the NOT, then an AND gate. Okay. So now P and R changes to. So this becomes 0. This becomes 0. But this is 1 and this is 1. This stage is called A. 0 and 1. 1 is 0 in NOR gate and 0 is passing here, it becomes 1. 1 into 0 is 0. What is the value? 0. 0, 1, 0. So 42 answer C. Q diagram immediately values values, that's all. Following configuration of the gate is equal to, this is which gate? Again we have to draw, then we'll see this is which gate is coming. NAND gate, both are going to AND gate. So I am giving A, B and this is Y. So this is OR gate, so this is A plus B, this is a NAND gate. So A dot B whole bar is equal to, I am simplifying, A plus B multiplied with the whole. So this can be written as A plus B into A bar Morgan's theorem. Correct? Then I multiply A with A bar. A with A bar is A dot A bar plus A with B bar, A into B bar. B into B. What is 0? This is 0. 0. So AB bar is 1. This is an XOR gate. So 43 answer B. This is an XOR gate. A PN photodiode is made up of material with a band gap of 2 electron volt. Minimum frequency of the radiation that can be absorbed by the material. Frequency they are asking. Energy is given. How to find out? Energy. Correct. We told H nu should be greater than or equal to energy gap. Greater than or equal to. So what is the minimum condition? Equal to. Correct. That is a minimum. So H nu frequency is equal to Eg. So nu frequency Eg is equal to Eg divided by H. Frequency hertz, so electron volt, 2 electron volt. How to convert into joule? Into 1.6 into 10 power minus 19 electronic charges to multiply. Then Planck's constant, 6.6 into 10 power of minus 34. You have to tell me what is the frequency. 5 into 10 power 14. 5 into 10 power 40 hertz. Average value of output current in a full wave rectifier is 2I0 divided by pi. Option D.